Um, I am going to go through more or less roughly of what do you need to be more careful about. I mean, as I said before, everything is important, and you will need to also for the theory. If you don't want to go through the videos, or about like the about very important parameters, for example, viscosity, and you don't know or you don't remember exactly what viscosity was, but you can also check the manual. That is very helpful for the theory. So a review about this is that you have to know the fundamental quantities, unities, and conversions of all our parameters, as mentioned in the first laboratory session and in the first lecture. You will also should be able to perform the errors. You should be able to note what is a random and what is a systematic error, and know how to calculate the percent of errors. I have asked you many times to do that in the lab, so I am expecting you to know how to do that. Also, to know what is the loading error. About the physical properties, you should know what is density, what is the concept of density, what is the concept of surface tension, what is the concept of viscosity and the specific weight, and so on. And for that, a very good way to refresh that memory, if you don't want to go through my videos again, you can read the manual, like for specific concepts. You have to know, or you should be able to know also the relationship between the absolute pressure and the gauge pressure, in which the absolute pressure will be the atmospheric pressure plus the gauge pressure. That is from the lab session number 2. So small concepts like that, if you know it very well, for the theory part, you won't have any kind of trouble, and you will finish very quickly that section, because you will have to have you will have some open-ended questions. You will also have some multiple choice and fill in the blanks, so you should be fine. So for the discharge over years, you have to know how to calculate the CD value from the graph H versus Q. So remember that I told you how to do the graph H versus Q, and also remember that graph had that little trick about log H versus log Q. You should be able to know how to do that also. So also, which one is more efficient? Remember, we analyzed the triangular one and the square one. So if we get a smaller CD value, which one, and a higher CD value, which one of them should be more efficient, and why would be using each one of those. So where they find an application. So remember, I told you that if we want to have a very high head loss, we would use the with the lower CD. So for the flow through a Venturi lab, you have to know how to calculate the diameter of the throat if the rest are given. So for example, you have the C coefficient, you have a flow rate, you have the differential head, and etc. And you will be able to calculate the diameter of the throat if everything else is given. Or if I give you the diameter of the throat and I ask you to calculate C or Q, you will be able to do it. And for that is the C coefficient big equation that for that lab report, and you have to be careful also about the units for those big equations. So for the discharge through an orifice, you have to know the description of the apparatus, and you have to know more or less of the background theory. Remember that apparatus had a lot of parameters within the apparatus, the arms between the between orifices, in order to get also the arm of the weight. So all of that you should be able to know, and also information about the background theory. So for the hydrodynamic force, you have to know the theory and calculations and results. For the hydrodynamic force, actually the calculations are fairly simple. There is nothing much complicated about that. So if you know about the theory about what hydrodynamic force is, and the apparatus used, you should be fine. And the friction losses in pipes, the lecture we just had, you have to know as well as any other lab reports, the background theory. For example, what are we calculating, or what is the gist of the whole experiment, especially the Reynolds number. You should be able to calculate the Reynolds number. In the lab report, you will be able to practice with this, to know the friction factor. You know about the friction factor I told you about. We have different ways to calculate the friction factor. You should be able to know or to be familiar with the equations. So for example, if I ask you to obtain the friction factor with a turbulent flow, and I give you the equations for the turbulent and for the laminar flow, you have to know which equation is for turbulent and which equation is for laminar. So you should be able to differentiate between the two of the type of flows. And also how to calculate the flow rate in the pipe, in which we will have been doing like for a long time by now. I'm sorry for the noise. So this is basically what we were looking, what I will be looking for in the final. As I said before, you will have 2 hours. I'm sure you can do it like in 1 hour or in way less time, but I really want to have, since this is an online exam, I really want you guys to have more of a window to, if something happens. And I will also be available during the final. If anybody has any questions, I will quickly reply.